chapter 5, the first section is exponents. And to begin with, I'm going to give you a few rules. This is called the product rule because it's of course used when you multiply. So if I have anything, I'll use a for anything, raised to an exponent, and then I have that same base anything raised to a different exponent, and you're multiplying those, what you do is you actually add the exponents. So multiplying, if you're multiplying the bases, you add the exponents, okay? And the base has to be the same and it stays the same. And the other one is the quotient rule. So the quotient rule says that if you have anything raised to an exponent and you're dividing by that same thing raised to an exponent, now you're going to subtract the exponents. Now, I also want to talk about when we have anything raised to the 0 power. And so I'll do that in just a second, but we'll want to appear right here with our rules. Okay, so to begin with, let's give you x raised to the second times x raised to the third. And some people go, oh, I'm multiplying, so they think they should write x to the sixth. But use your rule. Your rule says that you add the exponents. When you multiply the bases, they have to be the same and they're both x, you add the exponents. So it's x to the fifth. Add something like 5 to the second times 5 to the sixth. Sometimes this throws people because they go, oh, 5 squared is 25, but if the base is the same, you just want to leave it the same and then add the exponents. So 2 plus 6 is 5 to the 8th. And that's one that you could check. You could plug in your calculator and you could go 25 plus whatever 5 to the 6th is and see that it equals 5 to the 8th. Alright, what if I gave you y times y to the 4th times y to the 3rd? Now I have 3 of them, but they all have the same base, so I can just add all their exponents. And this is important to know. When nothing's there, there's an invisible 1. So I'll put it in a circle so you know I stuck it in. But don't forget, if nothing's there, there's a 1. So if I'm adding exponents, I now have y to the 8th, don't I? Now, to make it just a tinge bit harder, they'll probably go something like this. They'll give you coefficients with exponents times another coefficient with the same exponent. And they want to make sure you can keep your rules straight. So coefficients, you know how to multiply 7 times 6. Don't change that. 7 times 6 is 42. I can multiply. 42. And then I have y to the 5 plus 1. So y to the 6th. Let's try one more. How about negative 3x squared y to the 7th times 5x y to the 6th. So once again, multiply the coefficients like always, and you know a negative times a positive is negative. And then if they have the same base, you add the exponents. So 2 plus 1 is 3, and then my y is 7 plus 6, and that is my final answer. Now let's try our quotient rule. If I gave you x to the 3rd divided by x to the 2nd, our rule says that I can subtract those. And if you want, this is easy to think of because you've got 3 x's and you've got 2 x's. And x divided by x is 1, x divided by x is 1, so you're left with 1x. Or 3 subtract 2 is 1. And remember, when it's 1, you don't have to write it. When nothing's there, it implies 1. Is that glare? I don't know if that's hard to see or not. Alright. So, how about this one? Let's do a coefficient with an x. So, 36 divided by 9, I just do like I always have. The coefficients stay the same. But then, the base is the same, so I'm going to just go 5 subtract 2. 5 subtract 2 is x to the 3rd, isn't it? Alright, let's try kind of a sticky one. This is starting to look like ones you might see on kind of complicated. They like lots of numbers in them. So, let's do this. We've got 10/15, which we're going to just reduce like always. So 5 goes into that 2 and 5 goes into that 3. So that will reduce to 2/3. Now let's talk about our variables. Oh, same base. So I go 7 subtract 5. So I get a squared. Now, b to the 9 subtract b to the 9 is b to the 0. And this is where this rule comes into play. If 1. And that's true if I have variables. X divided by x is 1. Well, guess what? B to the 9 divided by B to the 9 is 1. So, we also know that if I'm dividing, I subtract. So B to the 9 divided by B to the 9 is also B to the 0. Ah, that's where this rule comes into handy. Anything raised to the 0 power is like you're dividing by itself. So it equals 1. And that's an important rule you want up here with your rules. Just go to 1. And so it won't be there. Your answer will be that right there. Let's make sure we're good at that. So if I gave you x to the 0, you all know that that should be 1, right? What if I give you a number to the 0? What's 8 to the 0? Guess what? That's 1 too. What if I give you negative 8 to the 0? Now this kind of throws people sometimes, because what it's like you have negative 8 to the 0 because you do exponents before multiply. So I still have 1, but now I have negative times 1. So it's negative. Now, don't be confused with this. If I had this, now that 0 is raising the negative. So again, that one will just be 1. You could even have two things in here. But again, it's like you're dividing by itself, so it's just 1. What about that is? Well, it's like having 5 exponent first, so x to the 0 is 1. So it's like having 5 times 1. So it is 5 that time. Alright, now we're going to learn one more rule. This rule says, I hope that's not a glare. I'm kind of worrying that it looks like a glare. Let me move my lamp. Maybe I should turn my lamp off. Let's see if that's better. I don't know if that's better or worse. You guys email me if you like the lamp or the not the lamp. But maybe I should write it up here by your rules. Says that if you have anything raised to a negative exponent, it is the same as putting that on the bottom and raising it to the positive exponent. And let's talk about why that is. If I had, let's say I had x to the 3rd divided by x to the 5th. Well, we know that our rule says when we're dividing, we can subtract. So that would be x to the negative 2, right? 3 subtract 5 is negative 2. We also know that's the same as 3 x's on top and 5 x's on the bottom. And we know anything divided by itself is 1. So that's 1, 1, 1. So what I have is 1 on the top and 2 x's on the bottom. So guess what? Those are the same. Those are equivalent. If I have anything raised to a negative exponent, I can put it on the bottom and make it positive. And do you know what? The vice versa is true too. If I have a negative exponent on the bottom, I can put it on top and it becomes positive. So we want to be familiar with that rule and be able to use that. And that will take us to the end of this section, 5.1. It asks you to simplify. For example, it just says simplify, and it wants you to simplify 7 to the negative 2. Now, if you tried, you can't even plug that into your calculator. It doesn't know how to do it. You have to make it positive first. So put it on the denominator, and then you know 7 squared is 49, and it's not bad at all. If you see a whole base raised to a negative exponent, now you put that whole base on the bottom and raise it to the positive exponent. And I think that's 81, but they might just leave it like that. What if I gave you 5x to the negative 4? Now, I give you this because some people think it's like this one and they move the 5. But look, the exponent is only on the x. So you only move the x to the bottom. Okay, only move what's on the base of the exponent. Don't move anything else. If it's in parentheses, that whole thing is the base. If it's not, only that base of the exponent gets moved. Let's make sure I don't throw you. How about this one? Now you know that you move the whole thing to the bottom, and it's raised to the positive 2. And it's possible they would go one more step and square both the 2 and the x, because they're both in parentheses being raised to the second power. Okay? How about this one? Let's see. I want that to be -3. So I have x to the -3 over x to the 4th. Now, what you might want to do is just take care of the negative first. So if I wanted, I could move that x to the 3 to the bottom and make it positive. Then I can use my multiplication rule that says if the base is the same, I add the exponents. So we have x to the 7. Oh, the base is the same, so I subtract exponents, which would give us 4 to the -3. But from now on, when they say simplify, they don't want negative exponents. So I need to go one more step and make that positive. Okay? And how about this one? Y to the -10 divided by y to the -3. Now, there's two ways to do this. One way is you could begin by making those positive, putting that one on the top, putting that one on the bottom. Then you could subtract. 3 subtract 10 is -7. But then we're back with a negative. So we know our answer has to be positive, so I put it on the bottom. Or you could start -10, subtract -3. We know that that is y to the -7, because subtracting a negative is adding, right? And then we have the same solution. We have to put it on the bottom. Let's try, what if I have x to the 5th divided by x to the -4? You could start by doing subtraction, or you could start by making it positive. So let's do it both ways. Let's say I get x to the 9th. Or we could begin by moving that x to the 4 to the top and make it positive 4. Now I don't have a denominator, and I know that I'm multiplying, so I add, and I get the same thing. So take them both, because you should get the same answer, and that will verify that you're right. Last one. How about 5 to the -4 divided by 5 to the -2? So again, we could start by making, and then I know that I subtract when I divide, so I have 2 subtract 4, and do a negative exponent, so I move it to the bottom, and then when it's that small, they'll probably do it. Now that's one way to go. The other way is subtract -2, and I go, oh, that means I've got 5 to the -4 plus 2. So I've got 5 to the -2. But I know I can't leave my answer negative, so I put it on the bottom. And then, if it's super small, they'll probably do it. So I get the same answer both ways. Alright, good luck on exponents. They're kind of fun. You might like them. I like that they're short problems, much shorter than Chapter 4.